Hi, Rahman here from the ELISE Customer Success Engineering team, and in this video I want to show you a short example on how to use our software with model-based system engineering tools like Cameo, Capella or Open Modelica, and how to use the metadata from these tools to automatically generate a 3D parametric model and perform first simulations to generate the first draft, which then can be used for further development. Before I show the example, let me explain a bit more with the help of the diagram that I've prepared here on the canvas. So basically, to fulfill the requirements of a new product or system, we have different tools at our disposal. And following the V model of the development process, we are going from an abstract definition of the system or product into a more concrete one. And this is where ELISE can bridge the gap between the abstract metadata, which comes from MBSE tools at the top level, and the concrete 3D models which come in later development stages. And this is because ELISE can use the metadata, which usually is in text, CSV or JSON format, and automatically turn them into 3D models and perform different actions, like for example, doing first simulations with our connectors to commercial FE software like Altair, ANSYS, Nastran, and so on. By doing this, the engineers can have first drafts very fast, and they have something they can see and evaluate for feasibility, and this will ultimately help them develop good solutions faster or help them in exploring different solutions. Now let us take a look at the example where we create the model of a wind power plant and perform first simulations on it. And for that I can open the example directly from the canvas, because this container includes the workflow for it. And by clicking on the symbol here, I directly open the file. And here you see the overview of the workflow. And this is also an example on how you can structure and document your work in our software. As for the example, we have 4 steps. And we begin at the left-hand side where we import the necessary data. In this case, it's a JSON file, which you can see here. And we have different parameters, like for example, the wind pressure for the simulation later, or coordinates for the wing characteristics, which we will use to generate the geometry. We import the data and give it into the next step, where we create the wind power plant that you can see now on the right hand side. Now that we have a geometry, we can go into the next step, which is to create a FE model. And for that, we define the load case and mesh the geometry. And afterwards, we give the FE model into one of our connectors to commercial FE software. In this case, we used Altair to run the simulations, and I already ran the simulation, so we can look at the results right now. After getting the results from Altair, we can evaluate them, and then go to the last step, which is to export the results. For the export, we can write another text, CSV or JSON file. In this case, we have written another JSON file, which you can see here. And we have checked the wind pressure criteria, which is set to true, which means it was fulfilled. But we could have also exported different stress values or exported the geometry or the FE model. And this is the whole process on how to automatically generate a wind power plant and perform simulations on it. Once you have defined this workflow, you can create any new version of the wind power plant automatically. And to demonstrate this, I will now replace the parameters in the background, and you will see that the changes are recognized and the geometry in the viewer will change too. So now I'm replacing, and you see that the workflow is running again. We now have a different geometry, and this geometry is again given into the FE modeler, and then the simulation is run again. And afterwards we will get new results that are written into the new file. And to speed up this process, I will now skip to the results. And here we have the new results now, and it is always a matter of computational power until you get the new results ready. And this is how ELISE can bridge the gap between the abstract metadata from MBSE tools and the concrete 3D models at the later stages of development. As always, if you have any questions, feel free to contact us at any time, and we will gladly give you a deep dive into our software and how everything works in detail. Thanks for watching.